new types of numbers. I mentioned it yesterday, but we're going to spend some time talking about fractions. Oh, I'll do a little thinner here. And everybody loves fractions. But basically, so, you know, we had the whole numbers or the counting numbers. Okay, so, you know, you start with the whole numbers and the counting numbers. Those would be like 0, 1, 2, 3, and on. Of course, then we talked about, okay, well, when you start subtracting numbers, if you take away more than you started with, well, then you get into negative numbers. And so when you introduce the negative numbers, that's how you get the integers. So the integers are all of the whole numbers, both negative and positive, right? Okay, so it's just a name for the class of numbers. But anyways, well then, so what happens is if you add and subtract any numbers and integers, you come out with integers. If you multiply any two integers, you're also going to get an integer, right? So it's like you take any whole number, negative or positive, and you multiply them, it's going to spit out another whole number, negative, positive. What happens though is, okay, well what happens when you start dividing numbers? So like for example, if I do like 2 divided by 3. Well, what is 2 divided by 3? It's not a whole number, is it? Right? You could write it as a decimal, you could write it as a fraction, but then what happens is that when you start dividing numbers, then you can divide two integers and end up with a number that's not an integer. So then you have to make room for more types of numbers, and that's where fractions come in. So then what you can do is we can introduce the fractions because of division, and then what you create are what are called rational numbers. Okay. And the rational numbers, we call them the rational numbers because fractions are like ratios. You know, a fraction is a ratio or like a proportion or something. So anyways, so when you introduce fractions, then that creates the rational numbers. And the rational numbers, these are basically all the integers plus all of the fractions. So, anyways. Okay? That's just kind of general information about why we use fractions. And it's because, well, you don't always end up with integers when you divide. Okay, so then some properties, we'll just go over some quick properties about fractions then. And then we're going to review some of the rules with working for fractions. That's kind of what Chapter 4 is all about. And so first off, fractions can be in a few forms, right? So like you could have a fraction like this is what we were just talking about, 2 divided by 3, which is 2/3. Okay, so in a fraction, right, the top number, that's what we call our numerator. The bottom number, this is what we call our denominator. All right. This right here, this happens to be an example of what we call a proper fraction. And why is it proper? Anybody know? Anybody know why we call that proper? Yeah, because it's not improper. That's true. It's called proper because it's not improper. But what about it makes it proper? Anybody know the rules? Or anybody know why? I'll show you. The difference is like we could have a fraction like 5/4. And then what happens here? This is an example of an improper fraction.
Because the larger number's on top?
Yeah. Now there's really nothing like, there's nothing particularly wrong with improper fractions. It's just that these represent quantities that are more than 1, right? So 5/4 is going to be bigger than 1. 2/3 is less than 1. So if the number on top is smaller, we consider it proper. If the number on top is bigger, we consider it improper. And the only reason is because 5/4 could be written as what we call a mixed number. Sorry, it wouldn't be 1 5/4. It would be 1 1/4. Okay, and this is the form we call mixed number in fractions. So there's basically three forms of fractions. None of them are really right or wrong. A fraction is just going to be proper or improper based on what you're dealing with. That's not good. But there's nothing really wrong with improper or mixed number form. Improper fractions, when we work with fractions mathematically, improper is a lot easier to work with. So, that makes it's okay to do that. But this is never how you would explain this quantity to somebody, right? Like if you said, how many feet, do I need to cut off of this piece of wood, right? Nobody would tell you to cut 5/4 feet, right? They tell you to cut 1 1/4 or something like that, right? So they both have their advantages. But anyways, so the point is that improper and mixed numbers, because they're both important, you want to be able to convert between the two. Okay, so you should be able to, like in this class, by the end of this class, you should be able to easily convert between mixed numbers and improper fractions, because we do it a lot. So let's look at how to do that. So let's say that you start with one's easier than the other, but let's say you're trying to go improper to mixed number. Okay. So if I have a fraction, so let's say 10 thirds. All right. Well, what's that going to be as a mixed number? You might just be able to figure it out.
3 1/3.
It's going to be 3 1/3. How do you know it's going to be 3 1/3? Because, 3 goes into 10 how many times?
3.
3 times, but 3 times 3 is
9.
9, so there's 1 left over, but we're in thirds. So what you're actually doing in your head there is you're doing the long division algorithm. And so if you can't do it in your head, you can do it by doing long division. And sometimes you're going to have to do long division. Like if it gets big. Now there's some ways around doing the long division. But I'm just going to review how to do it, just in case it's been a while since I've done it. If you're not sure how to do it. So what this is 10 divided by 3, right? So then we're going to actually say, okay, 3 doesn't go into 1, right? So it doesn't go into 1, but it does go into 10. How many times does 3 go into 10? 3 times, right? So you record it on top. And then what do? Then you check, what was 3 times 3? 3 times 3 was 9, and there's a remainder of 1. Now, you can go on into decimals if you want, but we're not going to worry about that. We stop right now. This is called the remainder, right, of the division. And so this one has a remainder, but what were we doing? It means there's 3 wholes, and there's 1 left over, but what is that 1? Oh, we were divided by 3. It's a third. So the way you do it, and then the answer is, 3, that's where that 3 comes from, and then this is, numerator, denominator. So it's just 3 and 1/3. So then if you get bigger ones, so let's say, is there another way actually you could do that? Anybody want to? There's like a way you can kind of cheat a little if you're trying to go 10 thirds to 3 1/3. That's going the other way. But if you go, one way you can do it is, especially when they get more complicated, you can use your calculator to figure this out pretty much, because 10 thirds, that's just 10 divided by 3, right? Well, plug it in your calculator. What does your calculator say? It's going to say 3.33333, right? It's going to say that, right? Well, so then the answer is going to be 3 and something. So your calculator tells you what the whole value is going to be, right? So the calculator says, it's going to be 3 and something. So then you can just figure out, what's 3? We divide by 3, so go back. 3 times 3 is what? 9. So how much is left over? There's only 1 left over. Does that kind of make sense? So you can kind of cheat with a calculator, which is fine by me. Or you can do it with long division. And it just comes in handy when things get, bigger. So like let's say it was, I don't know, like 115 over 9 or something like that. So if we were going to do the long division, right, we'd be putting 9 into 115. So, okay, so 9 doesn't go into 1, but it goes into 11. It goes into 11 one time, right? And you go 1 times 9 is 9, and you get your remainder for your first step. So then 11 minus 9 is 2, right? So then you bring down your next digit. You say, okay, well, how many times does 9 go into 25? No, it goes in 2 times, right? Because 2 times 9 is 18. And then you subtract, you have to borrow. 15 minus 8 is 7. And so that's your remainder. Okay? So then, if I'm turning this into a mixed number, I know it's going to be in ninths because everything's in ninths here. So what's the whole number? It's 12, right? It's 12 because that was the quotient. And then it goes remainder over divisor. So as a mixed number, that would be 12 and 7/9. When's the last time you did long division? Yeah. It's not. It's the thing is here's the deal. It's not like the most useful skill on earth. But do any of you guys know, are any of you guys going to take Math 60 after this?
Yes.
Like the algebra series? So if you're going into the algebra series, or like if you're interested in, if you think you're interested in like a STEM field where you're going to have to take like pre-calculus, you got to know how to long divide. So like if you're taking 60, 70 and going into like more of the STEM side, you actually do need to know long division because it comes back and it's important. So that's why we show it in this class, just to kind of as a quick review. It's not that important necessarily to know how to do long division to be successful in this class. And if you're going into Math 50, maybe not a STEM field, you won't really do much long division in your life, I'm confident. But anyways, this is how you long divide. So does anybody have any questions about that process? By chance? Did I lose you anywhere? Do you know where all those numbers came from? Please? Okay. Now, if it were me and I was going to do this, I probably wouldn't personally necessarily long. I mean, I might, but that's because I'm a math teacher. But if I was like out somewhere and someone gave me this task for some weird reason, I would just use my calculator. And I would do 115 divided by 9, right? So you pull it out. What's 115 divided by 9? Yeah, so it's 12.777. The 7 is going to go forever. Okay? So then I know my whole number is going to be 12. So now I just go back and say, okay, well, what is 12 times 9? Right? So that's 108. Right? And then you just figure out, well, what's left over from 115 if I got myself up to 108? Well, that leaves 7 left over, right? So then I know the answer is going to be 12 and 7/9. So, does that make sense? Any questions about how to do it that way? Using the calculator? So, I don't know which way is easier. I don't know. Some people like, I don't know. Whatever works for you, basically. That's the answer. But you do need to kind of know how to do long division. Okay. All right. So, going from improper to mixed number, basically all you just do is you do the division. That's essentially what you do. And if you do the long division, it'll give you the answer. You can divide in your calculator, but then you're going to have to work back a little to figure out what the numerator is going to have to be. Luckily, going the other way is much easier. So, like if we have a mixed number and we want to go to an improper form, and there's a lot of reasons we'd want to do that. So, like, let's say you have 5 and 2/7, or something like that. Okay. Does anybody remember the trick for going back to impropers? Yeah, it's a multiply. So we have 5 wholes, but we're in 7s. So what you can do is you can just say, okay, so this 7 times 5 is what? 35. So that 5 is like 35/7. So you multiply the denominator times the whole number, and then you tack on the 2 left over. So 7 times 5 is 35 plus 2. And that's how you would get that this is 37 sevens. So it's a lot easier to go that way. So that's just the rule. You can make it more complicated than that, but it's easier just to think of it as the rule. And you can check it. I mean, how many times does 7 go into 37? 5 times, because 7 times 5 is 35. How many left over? 2. Okay. Let's see. I'll just show you another one. So let's say it was like 13, or we'll make it negative. Negative 13 and 1/3. Okay. So then what? You got 3 times 13 is what? 39? Yeah, it will be negative. Our answer here will be negative, right? So 3 times 13, yeah, you could think of that as negative if you want at that point. Yeah, 3 times 13 is 39, and then 39 plus 1. So that's actually, you don't want to think of it as negative till the end. I actually saw this. I remember this now. This happened last quarter. I saw a decent amount of my Math 40 students did that. They said that 3 times 13, negative 13 is negative 39, and then when they added 1, they made it negative 38. But that's not how it works. Okay, the negative is just describing the quantity, so just do the regular rule. So 3 times 13 is 39 plus 1 is 40. So this would be 40 over 3, and then the whole thing is negative because it started negative. But you don't need to worry about like rules of negatives and positives when you're doing the conversion. It's just the rule. And then the sign stays the same. Okay? I'm glad you said something because I remember that coming out last quarter. Any questions on these? How I got any of those numbers on the board? You just feel like you can do that? Good, because you got to do that. So you have to be able to do that. So then the other thing about so there's multiple types of fractions. You know, you have improper versus proper. You can have mixed numbers. The other important thing about fractions is we always want to do our best to make our lives as simple as possible. And so in math, we always try to reduce our fractions as much as possible so that we're dealing with the smallest values that we possibly can be dealing with. Okay, so when you're reducing a fraction, what does it mean to reduce fractions? So like, for example, if I had a fraction like 4/8, right? Well, why is that not reduced?
You could reduce it to 2 plus.
Yeah, you can display this exact same quantity with smaller numbers. Yeah, and so like, because for example, and you know, yeah, I don't remember when last time you guys talked about pi in a math class, but right, it's like a pie split into 8 pieces, and you're taking 4 of it. Well, how much are you really taking? Yeah, you're taking half. So when you reduce a fraction, what you're recognizing is that they have common factors, and you're going to pull them out. So like you said, it could go down to 2/4. So you could do it in multiple steps and say, okay, I know both of these are divisible by 2. So what you do is you just divide that common factor on the top and bottom. So that would get you down to 2/4, which we also know would be the same quantity, because if you cut it in fourths and gave me 2, that'd be the same amount. But again, these are both divisible by 2, right? And so this actually reduces to 1/2, which we knew it was 1/2 because the picture told us it was 1/2, but right? And so the whole point of reducing fractions is that if you're going to talk about a quantity, you might as well talk about it in the simplest terms that you can, right? It's like, I could tell you that I could make you cut a pizza, and I could like say, hey, will you cut that into 8 pieces and give me 4 of them, right? But why wouldn't I just tell you to cut the thing in half and give me the half? It's way simpler. So anyways, if you're dealing with fractions, you just want to make sure that you always reduce them. That's the point. Okay. So like, I'll give you, let's say another example. Let's say if it was like, I don't know, let's go with 38 over, what's 38 even divisible by? 219. Oh, is it just 219? That's a bad example, but whatever. Let's go with something like 38/40 or something. What are those both divisible by? this is where it was good to kind of think about how to find factors. But these are both definitely divisible by what? They're both definitely divisible by 2, and you know it because they're even numbers, right? And so I always at least start there. If they're both even numbers, pull it out. Well, 38 divided by 2 is what? 19? And then 40 divided by 2 is 20, right? Can you go any lower than that? No, you can't, because what's true about 19? 19 is one of those prime numbers that's not divisible by anything. So once you get one down to a prime number, you can just quit. Okay. So anyways, be on the lookout for reducing your fractions. And then the simplest operation that we do with fractions is multiplication and division. Multiplication and division fractions are actually a lot easier than adding and subtracting. And so that's what I want to talk about. That's the last thing I want to talk about today. So first we'll look at multiplication. Okay. So when you multiply two fractions, say like, I don't know, 1/5 times, say 2/3. Okay. What's the rule for multiplying fractions? That would be cross multiplication. That's adding, and yeah, so that's the thing. The fractions have weird rules. Well, they're not weird, they make sense, but they're annoying sometimes. You don't need common denominators for multiplication and division, that's why it's simpler. But it's not cross multiplication. For multiplication fractions, it's just straight across. That's why multiplication is the simplest. So you just multiply straight across the numerators, straight across the denominators. So then this would just be, 1 times 2 is 2, 3 times 5 is 15. And that's it. Okay? You always want to check at the end to make sure that something's not reducible. So, like, let's say we had the fraction, say, 2/9 times, let's go with 12 over, I don't know, 15, or, well, let's not go 15. 16 or something, I don't know. That one's not even reduced to begin with, but. Okay. Now, what should we do here since it's multiplication? Yeah, you can always with multiplication just go straight across. 2 times 12 is 24. 9 times 16 is, what is it? 144. Okay, but now you got a big fraction and you need to make sure that it's not reducible because this one is. Okay, these are both divisible by what? They're definitely both divisible by 2, so I just start wherever. So if you recognize they're divisible by 2, go there first. Okay, well, so 24 divided by 2 is 12. 144 divided by 2 is 72. Okay, well, now what's true? Those are both divisible by what? Also 2, because they're even. So divide by 2, divide by 2. 12 divided by 2 is 6. 72 divided by 2 is 36. Well, what's true about those two? They're both divisible by? You could go 2, you could go 3, you could even go 6. 6 divided by 6 is 1. 36 divided by 6 is 6. 6. Okay? All right. Any questions about that? So multiplication is straight across, and then you want to check to make sure you can reduce your answers. And if you throw in negatives and positives, it doesn't really change anything. It's just you got to follow the rules, right? So like, let's say I had negative 3/5 times, let's say 8 over 9. So just like before, we kind of just ignore the signs at first and then we bring them back. So here, we'll just follow the rules of multiplication. So to multiply these, what do I do? Straight across, right? So 3 times 8 is 24. 5 times 9 is 45. And then you just remember, okay, well, what happens when you have a negative times a positive? It's always what? It's got to be negative, right? So then the answer is negative 24 over 45. But you need to check, is this reducible?
Yeah.
It is. They do have common factor. What's the common factor? What are they both divisible by? 45 is not divisible by 8. It's divisible by 9. What are they both divisible by? Yeah, 3? Yeah. So, and remember, I told you the trick for 3s is you can add them up and see if, like, 2 plus 4 is 6, that's divisible by 3. 4 plus 5 is 9, that's divisible by 3. So then they're both divisible by 3. So if we take the 3 out of the top and bottom, negative 24 divided by 3 is 8, and 45 divided by 3 is 15. And then that would be your solution. Okay. What questions do you have about that one? Feel okay about that? One thing you can do too, and you may have learned this at some point, but if you're multiplying fractions and you see at the outset that there's some numbers in the numerator that share factors with numbers in the denominator, you can actually simplify that ahead of time, because here I see that there's going to be a factor of 3 in my numerator, but 9 also has a factor of 3 in it in my denominator. So I know that in the end, I'm going to be able to take a 3 out because there's a 3 here at the outset. And so you can actually remove that at the beginning, and so you can divide the 3 out. So 9 divided by 3 is what? 3. And 3 divided by 3 is 1. So you divide that common factor out. As long as it appears in the numerator and denominator, just simplify it out at the beginning, and all you're left with on top is what? 1 times 8, and all you're left with on bottom is 5 times 3, which is how it gets you back to 8/15. It's also negative, but yeah? So if you ever remember doing that, like crossing things out and leaving numbers, that's what you were doing. You were simplifying those fractions before you multiply them. You don't have to do that, though. It's not required. You can always just multiply straight across first and then reduce. So, okay? All right. If you see, you can see things sort of like mashed together in terms of types of numbers. So if we had something like, say, 8 times 2/3, how do you handle that? Like a whole number times a fraction? Yeah. Whole numbers actually are fractions. You can write them as a fraction. You can write them as over 1. So anytime you see a whole number, you just convert it into, put it over 1 to make it into a fraction, and then you just, multiply like normal. So here, straight across, 8 times 2 is 16. 1 times 3 is 3. The other thing you can notice, this is just something I just remember, is if you're doing a whole number times a fraction, basically all you do is you just multiply the whole number into the numerator. Right? So it's just 8 times 2 is 16 on top. On bottom, it's going to stay 3. This would be a reasonable answer if all I said is just give me a simplified fraction. But if I ask specifically for a mixed number, how many times does 3 go into 16? 5 times, because what's 3 times 5? 15. So there's, 1 left over. So either one of those answers are correct. It just depends. You just got to be careful. Like on Canvas, sometimes I ask for it in a specific form, and then you just need to make sure you get it in that form. Okay. And again, it's just because this is the more mathematically nice thing to work with, but this is how you actually explain that quantity to someone. Okay. And then with that in mind, what happens is if you run into mixed numbers within like fraction operations, you typically want to get them out of that form. So like if I had, say, negative 2.5 times negative 1/5 or something like that. Okay, so if you're trying to work with fractions and you see this mixed number form, you basically just want to get rid of it. Okay. So what you want to do is you want to convert that into an improper first. So we want to get all of our fractions into improper form so that we can actually work with them. So what would this be in improper form? So 2 times 2 is 4. 4 plus 1 is, so this is negative 5/2 times negative 1/5. Now we can just go straight across. And we actually don't have to worry about the sign here because what's going to happen when I multiply these two numbers? It's going to go positive. Negative times negative is always positive. And so what do you end up with? Well, if you go straight across, you'd have 5 times 1 is 5. And then if you go straight across on the bottom, 2 times 5 is 10. But what are you going to end up doing? Reducing that by 5. 5 divided by 5 is 5. 1. 10 divided by 5 is 2. So the answer is just 1.5. Okay. But you could have seen that at this step. You could have also realized that there's a 5 on top and a 5 on bottom, and they're essentially just going to cancel each other out. And then you're just left with 1/2. 1 on top, 2 on bottom. Negative times negative is positive. So. Yeah? All right. Everybody feel like they can convert mixed numbers to impropers? Feel reasonably comfortable with that? Because that's the main thing that you really need to, I mean, multiplying straight across and reducing, most people are pretty good at that. It's just remembering that when you see stuff like this, it's like, don't panic. It's like, because that looks messy and kind of hard to deal with. But don't panic, just say, okay, I know at least I can put this into an improper fraction. And then once it looks like that, it's more familiar. So, okay? Now we got. All right, so then I got some ones for you to practice, the multiplication. So let's do that for now. I put some division problems down here at the bottom, but I'm going to wait on that and see how long it takes you to get through the multiplication. So you can just, with this worksheet I'm got now, you can just not do number 6, the last one. Just work on the first part and see how you do on this. Okay, so then if we're going to mixed number, what's 5 fourths? Well, 4 goes into 5 one time with 1 left over, right? So I'll go through some of these kind of quick. If you have a question, though, let me know. And then, so then 12 fifths. Well, how many times does 5 go into 12? 2 times, so that would be your whole number. 2 times 5 is 10, so there's 2 left over. Right? Then 29 eighths. How many times does 8 go into 29? 3 times, I think, right? Because what's 3 times 8? 24, so there's 5 left over. Any questions on those 3? Everybody able to get those mixed numbers? Okay. Perfect. Going the other way is a little easier because it's just multiply and add. 3 times 3 is 9. 9 plus 2 is 11. And it's over. Oh, stays the same. Yeah, denominator doesn't change. All right. 1 4/7. 7 times 1 is 7. 7 plus 4 is also 11. But this is 11 sevenths. So we're doing sevenths. And then 5 and 7 elevenths. 11 times 5 is 55. 55 plus 7 would take you up to 62. out of 11. Yeah? All right, any questions on those ones? All right. Mixed numbers will help if you're trying to plot things on a number line. So like on a number line, I would probably I'd center them as 0 because we're going negative and positive here. Yeah, maybe here's -1, -2, -3. 1, 2, 3. All right. So then we're looking at a fourth. So where is a fourth? The first one I asked you about was a fourth. Well, where is a 1/4 going to fall? So it's between 0 and 1, right? So within 0 and 1, right, like a half would be right in the middle. A fourth is going to be right here. Yeah? But if you're looking for where do you put 7/4, well, where does 7/4 belong?
That's number 1.
It's more than 1. Is it as big as 2?
No, it's 7. It'd be 1 3/4.
Yeah, so if you're trying to plot, so I'll go over here. If you're trying to plot a number like 7/4, you want to turn it into a mixed number basically, or you could do a decimal like 7 divided by 4. But 4 goes into 7, one time with a remainder of 3. So the mixed number does help you know where to plot it. It's beyond 1, but it's not to 2. It's 1 and then 3/4 of the way to 2. Okay, which except for I wasn't asking for that. We had it as 7/4. Okay, so there's 7/4. Yeah. Okay, then you've got 13/5. Again, if you want to figure out, well, where is 13/5? Well, 5 goes into 13 how many times? 2 times. 2 times 5 is 10, so there's a remainder of 3. So 13/5 is 2 and 3/5, so it's up here, above 2 but below 3. And then finally, -7/4. Well, that's just the opposite of this one, right? So -7/4 would be down here. It's just flipped from 7/4. So then now you already have them in order. So this would be the order from least to greatest. All right? All right, any questions on that one? Putting fractions on a number line? Feel okay with that, hopefully? All right, so then just a couple practices just with simplifying before actually doing the operation. Let's go back to black. So let's go 8, 24. What are those both divisible by? Lots of things. It actually doesn't matter what you start with. What did you see there? Yeah, you could start with 2. Divide by 2, divide by 2. That takes you down to 4/12. Divide by 2, divide by 2. That gets you down to 2/6. But then again, you can keep going. So it's going to be 1/3. It doesn't actually matter what you take out. You might actually realize that they're both divisible by 8 at the up front, but then you're just going to get directly to the answer anyway. So, yeah. Okay, so that one would be 1/3. Then what did I have? -63/99. What are those both divisible by? What's that? 3. 3 works. If you take out a 3, 63 divided by 3 is 21. 99 divided by 33 is, 3 is 33, but then those are both divisible by what? Also 3. So you take another 3 out. 21 divided by 3 is 7. 33 by 3 is 11. So 63/99 will reduce to 7/11. Yeah? All right. Just stop me if you have questions. And then what happens if you start throwing letters in there? What do you think? Yeah, you basically, the x and the y are different terms, so they're just going to stay x and y on top. Like, they can't cancel out. But the 3/12 is reducible because they're both divisible by 3. So then you just have 1, 3 divided by 3 is 1 on top, 12 divided by 3 is 4 on the bottom. But we don't actually normally write this 1 times in math. It's kind of redundant. So really probably actually that would be the most simplified way to write that. Would be with just x on top. But So if you see letters in there, it's fine. You can just reduce the coefficients in front of them, the numbers attached to them, and then move on. We won't deal with that as much, but we'll get into algebra with more variables. So, all right. Everybody feel okay up to that point? All right. So then, when we get into the actual multiplying, so 1/2 times 3/8. This one you can't reduce ahead of time, so we're going straight across. So 1 times 3 is 3. 2 times 8 is 16. And that's all you got. Yeah? Just stop me if you want me to revisit an example. So then here we got negative 3/4 times 4/9. If you want to multiply straight across, you can. Or for me, I would see that these 4s are going to cancel, right? Because there's a 4 on top, 4 on bottom. And then what about 3 and 9? 3 divided by 3 is 1, and 9 divided by 3 is 3. So actually all you're left with is a 1 on top and a 3 on bottom. And a negative times a positive is negative. If you multiplied straight across, though, you'd be fine. So say that you multiply straight across the beginning. 3 times 4 is 12. 4 times 9 is 36. Then you can work your way down, because these are both divisible by 12. 12 divided by 12 is 1. 36 divided by 12 is 3. And so you just get right back to the same answer. So, okay. All right. Questions on that one before I move along? Do you guys feel pretty comfortable with this? Hopefully. Okay. It's good if you do. So the next example was 5/12 times 8/15. Again, I like to simplify ahead of time. So I see a factor of 5. So 5 divided by 5 would be 1, and 15 divided by 5 would be 3. What about 12 and 8? They're both divisible by 2, even 4, right? So you could say 8 divided by 4 is 2. 12 divided by 4 is 3. And all you're left with is 1 times 2 on top and 3 times 3 on the bottom. So the answer would be 2/9. Okay. The advantage of doing the reduction ahead of time is that then you don't end up with as big of numbers and you don't have to reduce. You don't have to reduce at all because you know that your answer is reduced because you did the reduction ahead of time. Right? So that's the advantage. Because a lot of times, most of the mistakes I see are just mistakes in reducing. So, all right. The next one, you got a negative times a negative. So really, we know that ultimately, what's our sign going to be? It's going to be positive. So, but 9 and 33 are both divisible by what? 3. So 9 divided by 3 is 3. 33 divided by 3 is 11. And 25 and 10 are both divisible by what? 5. 25 divided by 5 is 5. 10 divided by 5 is 2. So what are you left with? 3 times 5 on top. 2 times 11 on bottom. 15 over 22. And it's positive. So. Okay. All right. Then you got 2/9 times negative 12 over 5. There's not much to reduce here, but 12 and 9 do share a what? A 3. 9 divided by 9, or 3 is 3, and 12 divided by 3 is 4. So you've got 2 times 4 on top, and you've got 3 times 5 on bottom left. And a positive times a negative is going to be negative, so it's going to be negative 8/15 for that one. Okay? And again, you don't have to worry about reducing because you already did it ahead of time. All right, and then the last one I got there, it's one where you've got a whole number. Yeah, so then you could just rewrite that as negative 8 over 1 times 5/6. And then multiply straight across if you want, or recognize 8 and 6 are both divisible by 2. So 8 divided by 2 is 4. 6 divided by 2 is 3. And then a negative times a positive is negative. 4 times 5 is 20. 1 times 3 is 3. And that would be a perfectly decent answer. I did mention, though, in the directions, also give the mixed number representation of the answer if it's applicable. So in this one, it is, because how many times does 3 go into 20? 3 goes into 20 6 times, because 6 times 3 is 18, remainder of 2. So that would be the same as negative 6 2/3. If you had to have the mixed number representation. Okay? All right. If you have any questions and you want to stick around and ask them, we got 5 minutes left. But otherwise, that's all I got for today. Or well, actually, only 3. That's all I got for today. We'll do some division and some more practice when we come back. But we don't have class on Monday. Monday's a holiday, so I won't see you guys until Tuesday. Holiday. On Monday?
Veterans Day?
No, Martin Luther King Jr.